I'll be your host, Ben Ochoa. Woo! Yay! All right. So this session, what we want to do is focus on how to apply some of this knowledge that we learned this week and last week into our Cath Lab setting. Right. So as you may have seen in the video, you got a nice little broad introduction to the contents of the cardiovascular system. That's our main target as techs. So we'll be, in the cath lab performing procedures, both diagnostic and interventional. So in order to let's see, let's just start with diagnostic procedures. In order to do diagnostic procedures, we need to be able to define what's normal in the heart. So when abnormal things happen, we're able to kind of detect it. So let's just go ahead and we'll start there and we'll start defining normals. All right, class, what you see before you is an interactive Wiggers diagram, or as we like to call in the biz, like the Rosetta Stone of the heart. So this is a cool diagram right here, and this is pretty much what we're going to be mainly focusing on here in the semester is just kind of defining each element of this diagram. And what this does is it kind of lays out a good representation of what's normal in the heart. So we have what normal EKG, we have normal pressures, we have normal heart sounds, and when the heart sounds occur, we also have the different phases of the heart, which we'll kind of build on as we go along. All these things, and we also have, a visual representation of each of these things occurring. So this is really helpful to aiding in your understanding. So let's go ahead and take a closer look. All right, let's go ahead and talk about our main veins first. Let's talk SVC and IVC. So let's take a closer look at the SVC. It's a low pressure system. Typically has about 70% O2 saturation going right there. And then let's go ahead and take a look at the IVC, which is also a low pressure system um, and has about 80% O2 saturation of blood going in there. And the reason why there's a difference is because the brain takes up a lot more oxygen. Yeah, I would hope so. All right, so let's go ahead and move on to the chamber, which both of those main veins dump into, which is the right atrium. Right atrium is also going to be obviously the low pressure system as the blood kind of passively fills and flows through into or through the tricuspid valve into the right ventricle. So if we take a closer look and we see the values of the right atrium, of course, we see the different, we see that the right atrium is 75% O2 oxygen saturation. We also see that there's different events that occur that are measurable in the right atrium. We see the different waves that we pick out and we put a value to, which are your A and V waves, of course, and then you have your X and Y descents, and then sometimes you can see the C wave right there too as well. And you can see the definitions of them right above there. All right, so let's go ahead and move on into the through the tricuspid valve into the right ventricle. Okay, so if we take a closer look, we see the right ventricle has same oxygen saturation as the right atrium, 75% normal. We also see if we take a closer look and we see the different events of the heart being represented by the pressure waveforms, we see that the ventricle has pretty much two, major events going on, pretty much systole and diastole. And if we go ahead and look further, we could see, a little bit more detailed of the waves and some of the other things that are occurring. And we'll kind of get into that a little later with flow dynamics. All right, so next up, we'll go into the PA. And the PA or pulmonary artery, we go through the pulmonary valve to get there, and the pulmonary artery breaks up into two separate trunks right there. And let's see, the O2 saturation is going to be continuously 75% going through. And then we're going to look at the pressure wave. And then if we take a closer look, we can see the events and the different definitions of the wave itself right there. All right, so we have the blood flowing through the pulmonary artery, going to the lung bed, and then gathering all that oxygen, and then returning via the pulmonary veins, all four of them. So the pulmonary veins empty out into the left atria. If we take a closer look, we see that this system is a low pressure system, just like the right atrium. But in this instance right here, we see the oxygen saturation at about 96 to 100 going through here. And then let's see, then next we go through the mitral valve into the left ventricle. So the left ventricle is very similar to the right ventricle in its pressures, or I guess they're pressure waveforms. just like the left atrium is very similar to the right atrium. So if we take a closer look, we have the same events happening. However, on the left side, it's going to definitely be a lot higher pressure than on the right side, of course. So also, we see that the O2 saturations are same as the left atrium right there, between what 96 and 100s. So next up, we go through the aortic valve into the aorta. So aorta, just like the pulmonary artery, has very similar events, pressure waveform events to it right there. And just like the contrast, it's definitely the pressure is going to be higher on the left side. And if we take a closer look at the O2 saturations, we can see that the O2 saturation is between 96 and 100 right there. All right, and that concludes our structural heart tour for the evening. As you can see, we collect various amounts of data to kind of tell us the story of what's going on in the heart. I hope this little thing was helpful right here. I'm going to be using that interactive Wiggers diagram a lot more for lessons in the future, as well as other, visual aids. So, hope you all have a great week. All right, bye.